Hello, everybody, and thank you for being here today. My name is John Ellis, and my company is Dynamic Air Consulting. And again, just thank you so much for taking time out of your busy schedule to be here with us today as we dive into indoor air quality. Where do we start? So, as the owner of Dynamic Air Consulting, I work with clients all over the United States on complex indoor air quality issues. And I provide in-field coaching for HVAC contractors during the discovery, design, and implementation of IAQ solutions. Let me tell you a little bit what that's about. So I'm able to go in the field with clients, and I use that opportunity to coach HVAC contractors. So I bring my testing tools, my experience, and we have an interview with the client to understand exactly what their needs are. And then we go in and do some testing and test our way out of the building. And then we sit down at the end of the day and we have a discussion with the homeowner on a scope of work. And then it's up to the contractor after that to give a bid and hopefully sell that IAQ project. And we've had great success with that. I served as project managers on large projects on schools, prisons, hotels, water treatment plants, hospitals, and I worked on a year-long pilot study with the South Coast Air Quality Management District, installing and testing high-performance air filtration in schools, and that was in Southern California. Before that, I had a company called SoCal Air Dynamics in Southern California, where I was a performance-based contractor using a unique blend of building science, building forensics, and mechanical science, creating clean, healthy indoor environments for people with severe respiratory compromises. My clients came to me with a wide variety of respiratory issues, including cystic fibrosis, COPD, oncology, lung transplant recipients, immune deficiencies, debilitating asthma, and garden variety seasonal allergies and the such. During my career, I have had numerous certifications, building science, EPA renovator, commercial system performance, commercial air balance, level 1 thermography, quality installation. I was a HERS rater. I was BPI certified and helped commission LEEDs buildings. As using my commercial air balancing certificate, I was able to do large projects. I've probably got 1,000 systems that I've personally commissioned. And in doing surgery centers as well, where they look in depth at building pressures, room-to-room pressures, moisture, humidity, air exchanges per hour, infectious disease rooms where you condition the room, but you take 100% of that air to atmosphere. So it was really quite interesting what you're able to accomplish just by looking at the air side of things and doing air balances. I've been in several trade organizations like National Comfort Institute, Indoor Air Quality Association, and the Institute of Heating and Air Conditioning Industries, IAQ. So fast forward, I now am a service trainer for the new flat rate, providing on-site training for plumbing, heating, and air conditioning companies. And now I am teaching indoor air quality principles workshop for the Amana Brand Business Academy. And that's what brings us here today. So the class description, we'll be looking at addressing indoor air quality issues using 5 key areas that already are a part of our everyday HVAC practices. So this includes thermal comfort, humidity, building pressures, ventilation, and filtration. These terms should already be familiar. This is stuff we do every day as HVAC contractors. If we're able to look at these 5 key principles, this goes a long way into offering indoor air quality solutions. So let's jump right in. Let's start with thermal comfort. Controlling thermal comfort is very important for indoor air quality on how our clients feel. Rooms that are too hot, too cold, or too clammy all add to the discomfort factor. And in controlling thermal comfort, airflow is paramount on how our systems perform and function. Without airflow, nothing happens. We have problems with the heating cycle. Too little airflow, and we go off on high limit. Too much airflow, and we don't have enough or long enough run times to take care of the mean temperature loads. And air conditioning, too little airflow, and we don't have a complete refrigeration cycle. And also too high, we have too high of airflow, and we have an imbalance on our sensible latent ratio. Therefore, throw and spread are also important from our registers and drastically affect thermal comfort. The same holds true for indoor air quality. We get stagnant pockets of unconditioned and unfiltered air and can cause undesirable conditions. Airflow also controls the number of air exchanges per hour that we get within conditioned space. So airflow is just everything. How much air flows through our filters, across the heat exchanger, also across an evaporative cooler, are all big concerns of ours as HVAC contractors, not only on the system performance side of things, but also on indoor air quality issues. So getting your airflow spot on is really paramount in everything we do as HVAC contractors. As HVAC contractors, we should have some basic understanding of IAQ principles that we are already doing every day just by controlling thermal comfort. And next on our agenda, let's talk about humidity. Controlling humidity is huge in the world of IAQ. Too much humidity and you have an environment conducive of microbial growth, dust mite colonies, and structure degradation, not to mention extreme discomfort. Humidity is a huge problem and is often different for different parts of the country. So what happens in California is a lot different than what happens in the South with high humidity swings. Texas, what I like to call the humidity belt. Too little humidity and dries out the mucous membranes in the nose. Now the mucous membranes are our body's filtration system. And so once you dry those out because they're too low, we have the inability to filter stuff that comes into our bodies. When we inhale different particulates, especially ultrafines, that has an opportunity of getting into the lungs, getting directly into the bloodstream, and can cause all kinds of health issues. Other evidence too, a little humidity is found when we start drying out building materials. I've actually seen wood veneer on cabinets and furniture and start to dry out just because of the humidity, low humidity within a building or structure. Low humidity can cause pollutants to stay airborne for longer periods of time and cause high static electricity. We've all had that opportunity where we go scooting across the carpet and go to touch a doorknob or our loved ones, and there's an electric shock that happens. So that is caused by low humidity. How we control humidity can be achieved several ways. Determining the ideal humidity comfort zone should be based on the client's needs. But depending on who you ask, the ideal climate zone or humidity should be around 45%. Anything below 30% is too low. Anything above 55 is too high. So the most common way we control humidity is through the refrigeration cycle from the air conditioning. We refer to that to the latent side of the cycle. So our air conditioning does work. We call that sensible and latent. In the drier side of the country, let's say from New Mexico, California, Arizona, Nevada, we look at about 70-30, 70% sensible and 30% latent. as you get into the what I call the humidity belt of the country, you want to do probably the opposite. You want to do 70% latent and 30% sensible. Making sure that you measure and adjust your system to the right ratio is huge. And that's something that we should be doing in our everyday businesses as HVAC contractors. The problem that we see across the nation is oversized equipment. This is going on, again, across the nation. So oversized equipment doesn't allow long enough run times, doesn't allow the system to properly condition the air and remove humidity. Oftentimes the air will cool down or heat up faster than the surface temperatures and causing a short cycle in the system. And that is not conducive for a good IAQ environment. By speeding up or slowing down the airflow, you can change the humidity removal. Having a system that's doing too much sensible in a humid environment will create a cold and clammy situation. That feels very uncomfortable, and I've been in buildings and homes where that's exactly what's happening, and it is uncomfortable. Adding a separate dehumidifier can tackle some tough humidity problems. Keeping in mind finding the source should be priority. This is going to be a theme throughout my presentation. Source control is huge. Identifying the source and coming up with a solution on how to control the source of a different situation should always be first in mind before we start adding equipment and gadgets to help have a quick fix on some issues. In colder climates, adding humidity is common practice as a humidifier, and this can go a long way into helping with low humidity issues. And of course, sizing is important. Do your research before installing any kind of equipment, and knowing what your parameters are and what you're trying to achieve. So in short, controlling humidity for our clients is a great opportunity for some solid IAQ approaches for your clients. Let's talk about building pressures. Controlling the building or envelope pressures is greatly misunderstood, but totally a part of our responsibility as HVAC professionals. Let me be clear, when a house is being built, it is the contractor or general contractor's job to see that certain standards are being met as far as building tightness. But we don't always have that luxury. We work on a lot of older homes, which are very leaky, but we still have the opportunity to control the building pressures, even in an older home. That being said, older homes and buildings we can control the amount of air that enters or leaves the structure. Knowing the infiltration rate is a big part of doing our load calculations. 1 CFM in equals 1 CFM out. 1 CFM out equals 1 CFM in. When we're talking about air moving in and out of a building or a structure, that is huge when we're doing our load calculations. When it comes to IAQ, all the filtration in the world is a wash if our infiltration rates are not addressed. Let me explain this. I test houses all across the United States, and one of the first things I like to do is baseline a home. So in doing this, I want to take my pressure readings in relationship to outside. So many times I start off in a negative pressure with nothing running, all doors and windows shut, just the building by itself, and I'm in a negative pressure. This happens several ways. So we have some driving forces, and we're not going to go too deep into this because we're starting to get into the building science realm of things. But as the house starts to warm and cool, we have convection loops within the home, and this can cause negative pressure. So when a house or structure is even in a slight negative pressure, this has a possibility of bringing in pollutants from outside. Remember that air is the medium on which all things travel. So if we're bringing in air from outside that's unconditioned and unfiltered and untempered, we have the opportunity to bring in moisture, humidity, VOCs, microbials, dust, chemicals, rodent feces, and the list goes on and on and on. So building pressures is huge in looking at an IAQ solution. Knowing how to measure them takes a little bit of practice and some additional training, but it's well within the realm of an HVAC contractor to understand and address building pressures. Looking at building pressures allows us to identify source of pollutants. Of course, sealing up the structure would go a long way, but we can control the pressures in a couple different ways. So again, I'm referring to finding sources of pollutants entering a building, and building pressure is always at the top of my list on when I'm trying to track down sources of pollutants. So assuming we have a balanced system for the HVAC system, heating and air conditioning, bringing in a prescribed amount of air, and I want to put the emphasis on prescribed. So you have to know where you're at by some simple measurements to know how much air you need to offset the building pressure. So bringing an outside air duct into the return air would give you a positive pressure, assuming that we have a balanced system. But that isn't always possible depending on what part of the country you live in. So my contracting business was in California, and I'm able to get away with things in California that I couldn't get away with in other parts of the country, like let's say Minnesota. I just spent 2 weeks in Minnesota working with a company, and we have some huge temperature swings along with humidity from summer to winter. So just bringing an outside air duct directly into the return air is not really acceptable in that climate. And also in Houston during the summer, where the humidity levels are so high, you wouldn't be able to get away with that. But I was able to do some of that in California, Arizona, and some of the surrounding states. It takes a little bit of practice to learn how to mix the air before you bring it in, but it is a possible solution. So solving positive pressure can happen a couple different ways. An ERV, an HRV, and even a dehumidifier with bringing air from outside into the building will help you offset a negative pressure. But again, having those measurements and knowing where you are as the starting point and where you need to go is paramount to even start to understand how to offset the pressures. So having positive pressure device both tempers and filters the air before it brings it in. Most ERV, HRVs have like a MERV 8 filter in it. A dehumidifier doesn't, but you can add a filter to it if that's going to be part of your scope of work in offsetting building pressures. So moving right along. Let's talk about ventilation. We are HVAC contractors. The V stands for ventilation. Fresh air, or outside air as it's often called, falls under the category of ventilation and is widely overlooked as part of IAQ solutions. Take the V out of HVAC, all we have left is HAC. The benefits of bringing fresh air are amazing on many levels. Let's start with dilution. This is a process of diluting harmful pollutants in a house, such as carbon dioxide, some VOCs, cooking odors, pet odors, and the list goes on, by mixing indoor air with fresh air. Often by diluting such compounds, we bring in fresh air and the levels are brought down to safer concentrates. Of course, we always want to try to identify the source of the pollutants and eliminate them. So again, this is going to be a common theme. So if you have high carbon dioxide, one, you have to identify where it's coming from. We would like to eliminate it. And then we can talk about diluting it. So if you can't eliminate it 100%, then diluting it would be a solid approach for an IAQ solution. VOCs, of course, we would have to identify the source. That is a tough one to track down, but it is important. Are the sources of the VOCs internal within the structure, or are they external and coming in? And is a dilution a solid approach on that, or are we going to have to lean our attention more towards eliminating that source? So bringing in a prescribed, and I put the emphasis on prescribed amount of fresh air helps control stagnant air in a house or structure. Recirculating the same air over and over again can become a problem. In today's housing market, homes are being built tighter and tighter, allowing pollutants to build up with nowhere to go. So if we start with a home or a structure that's being built, and you have your basic construction components, so we like to call that a pressure boundary. So you have the four walls, the floor, and the ceiling. And so certain products are being used, such as paints, carpeting, glues, laminates, even furniture, as you bring them into the home, can and do have a certain amount of VOCs attached to them. Carpet glues are high in VOC, and yes, they will dry, but depending on what climate you're in, they take longer, and even concrete as it dries can emit some VOCs depending on the mix. I know in colder climates, they do what's called a hot mix. And so there's more chemicals involved into trying to get it set up. And depending on humidity, they cure, and then the moisture and humidity will bring them back. Building furniture is a big one. There's a lot of formaldehydes that are used in furniture and some building materials as well. So once those are all brought into a structure and the building is tight, there's nowhere for it to go. And they build up, and sometimes they can build up to an unhealthy level. So taking a look at sources is important. ASHRAE standard 62.2 states that a building air tightness gets at or below 0.35 natural air exchanges per hour, we must introduce mechanical ventilation. So depending on what part of the country you live in, ASHRAE 62.2 is becoming huge. And I'm going to use California as an example because that was my marketplace. But right now, they are putting into code that you shall have a certain amount of outside air or ventilation. They're also stating that you must have a MERV 8 filtration within your system. They're calling out for refrigeration standards and also fan watt draw and duct tightness. So those are all measures that are being implemented and becoming standard and have to be measured by a third party. So knowing how much ventilation you need is a matter of taking measurements and testing, because if you don't test, it's just a guess. So as I stated earlier, bringing fresh air also helps building pressures. How we bring in fresh air varies depending on the climate. Again, using an ERV, an HRV, or even a dehumidifier to bring in the fresh air is very effective. So let's put the V back into HVAC and not become hacks. So just a reminder, keeping the whole house ventilated is a must. Filtration. So as HVAC professionals, every single one of our systems should have a filter in place. Filtration is commonly the mechanical or physical operation which is used for the separations of solids from fluids. Air is a fluid, and the filter allows the fluid to pass through a medium, removing any solids. Filters were originally installed in heating equipment simply to protect the equipment. I like to call these filters doing birds, bees, and bats and nothing more. As consumers started adding air conditioning to their homes, this became even more important to keep the debris out of a wet evaporative coil. During the energy crisis, homes became tighter and tighter, and IAQ got its roots. Consumers expected filters not only to protect the equipment, but also keep the home clean and dust-free. This led to the evolution of more and more HVAC-related IAQ products, such as newer filter types, fiberglass, electrostatic, pleated, extended pleated, HEPA, and electronic air cleaners. There is a wide variety of filters on every shape and size and thickness, and different filters claiming to do different things. The 5 most common filtration methods are impingement, interception, electrostatic attraction, and diffusion. Most filters on the market today only use 1 or 2 of these methods. The benefit of using a better filter, of course, improved indoor air quality. The downsides, oftentimes these filters are not designed into the system and are very restrictive and can lead to airflow problems. So in our industry, we have adopted a standard called the MERV rating, and it simply stands for minimum efficiency reporting value. So they are tested in a lab for the arrestance of particles. So some filters, if you look at the manufacturers, will give you some data that will tell you what the pressure drop is and what you can expect at different velocities. We have a filter manufacturer out there in the big box stores called 3M. They're actually fabulous filters, but they are very, very restrictive in the airflow. And they're a great company, and they have adopted their own MERV rating, if you will, and they use stars. So if it's a 5-star, it's a better filter. But again, knowing your parameters before you design a filter is important. So filters are designed to move a certain amount of air, cubic feet per minute, CFM, at a certain velocity, that would be feet per minute or FPM, through a certain size opening area in square feet, with a certain restriction of the airflow, and that's called pressure drop. So all these measurements must be taken into consideration before you put a filter in a system. So let's talk about another thing about filters is how they're installed. I've seen filters installed the darndest ways. One way, if a air handler is in a closet, the filter simply slips in underneath the blower assembly with a little wire clip to hold them in place. And homeowners, doing the best they can trying to change their filters, they fight that little wire clip, and a lot of times they end up going away. I call these floaters. So when the air comes on, that filter floats, and it's basically not filtering anything at all. Another thing I see is a filter slide or a rack for a side discharge, where they tap the return air duct into the side and they slide that filter in, and it's not tight at all. And we have a lot of what's called blow by, and that drastically reduces the effectiveness of a filter, especially after it starts loading, and air will find the path of least resistance and go around the filter. And then I've seen where people will take a electronic air filter housing, pull the elements out and toss them, and just slip any filter that might fit inside there. And of course, that becomes real problematic, again, because of what we call blow by. The air is not passing through the filter and simply going around. I've had people pull out a standard 1-inch filter that was designed or not designed into a system and put a 3M filter in its place with huge restrictions to the airflow. And now their coil is freezing up, or their furnace is going off on high limit because there's not enough air across the heat exchanger. And again, this is very problematic. So designing a filter into your system is paramount when using filtration as an IAQ solution. So again, this is something that we do in our everyday business as HVAC contractors. I have one last point I'd like to make, and I want to talk about the human element. When working with clients and their families, more often than not, there are heightened emotions attached to the decision of needing an IAQ professional. When children are involved or severe medical conditions, emotions skyrocket. I've worked with families all over the United States. Remember, they are looking for solutions and answers, not products and widgets. You must also remember that prescription without diagnosis is malpractice. I have the opportunity of working with some amazing families all over the United States, uh, working with children, and have established some amazing relationships. And I'm in contact with those families to this day. Um, I can't tell you how many times I've heard them state that, oh my goodness, we've had every contractor we could possibly get a hold of, and they're all saying the same thing. And they all want to sell me something. Insert name of product here. And said, we just need answers. And they're working with their doctors. Sometimes I have the opportunity to talk to their doctors and help understand the direction we need to go, and sometimes not. But they want answers. They truly need answers. And the more severe the condition or medical situation, the more they're looking for answers. And by the time I get to them, they're very well researched in what's going on with their home and with their children or a loved one in their medical conditions. So this is a huge opportunity to work with clients and give them true indoor air quality solutions. I'm very passionate about it. And the opportunities that I've had to really work with some families and the rewards that come with that are priceless. Um, to help you with diagnosis of indoor air quality issues, I want you to remember one thing. Indoor air quality equals investigate, analyze, and quote. So there has to be a discovery phase of offering an IAQ solution. We go in and it starts with sitting down with the client and just shut up and listen. They will tell you a lot of what they need to know. This is something that they've been living every day, day in and day out. They know what they need. They might not know how to get there, but they will tell you what you need to know. Just listen. Have compassion. Have a heart to really hear what they're saying. The next would be analyze. Once you go in and have a discovery stage, you've taken data, you've looked at everything you need to see, and you're working your way out of a structure. You need to analyze the data. You need to really look at the information gathered and make a decision based on data. Not, oh, I read an article here and this is supposed to do this and this is supposed to do that. That doesn't hold up when you're offering indoor air quality issues to people who really need your service. And then lastly, quote. You cannot quote an indoor air quality job until the first two are done. And based on the information you gather, based on the process of listening to your client, then you're able to quote a solid indoor air quality solution. Indoor quality is such a missed opportunity for contractors to serve their clients well. It is also the most misunderstood part of HVAC. So join me on this journey and really dig in and learn what you need to know to offer IAQ solutions. We have barely begun to scratch the surface of indoor air quality. The topics today are right in the wheelhouse of HVAC contractors. This gives you a great starting point, a launching point, a little bit of a foundation to get started. With additional training, tools, and practice, you can become an industry leader in the realm of IAQ. Remember, if you're not standing out, you're just blending in. If you'd like to learn more about indoor air quality principles, visit the Amana Brand Business Academy website. Sign up for our Indoor Air Quality Principles workshop. This 2-day workshop will take you deeper into the world of indoor air quality and better prepare you to offer real solutions. This course is also approved for 16 CEU credits. I would like to thank everybody for taking time out of their busy schedule today. I know we have a lot to do in running our businesses and just our everyday day-to-day operations. And thank you to my wife for being such a great support and helping me through all of the IT and the technical part and all the background stuff. Couldn't do it without her. So again, thank you for coming and have a great day.